Hello everyone, and today I'm going to draw a little diagram explaining how exactly the network architecture works for this year's National Cyber Defense Competition, i.e. 2019. There's been a bit of confusion had among teams as to how exactly this is structured and why things are how they are. While it may not be the most intuitive solution, this is part of the challenge is fitting into the scenario we have provided, and this video should help explain some of the more prominent questions that people have as to how exactly things communicate and what your pipeline should look like. Possibly this may provide insight on the debugging process. So something to understand is that all of your bank information comes from a central bank system. This is hosted by White Team. This is the only bank, really. And inside this bank is a virtual file system served over the 9P protocol with everyone's banks indexed from 0, which is ours, the master reserve for White Team, and then each number after that representing a given team. So in this case, 3 would be Team 3's. This service, as it's served over 9P, is locked behind authentication. There are respective with each of these banks, except with really exception to this one, i.e. White Teams. There is an account associated with it. For, say, Team 3, you have an account named Team 3, and in iScore you should have credentials that reflect this. I believe it's around 25 characters. This information is used to authenticate into the bank and access your team's bank information. That is, if you were Team 3, you would mount the 3 bank, and you would use that to control the state of your bank and communicate to other accounts. The bank takes care of all the transactions. You may formulate them, but you may only propose them to the bank, and the bank may reject them at any given time. To this end, the services that you host, i.e. on your network, and this could theoretically be all in competition, or they could be on your private network, include a bank to node box, a node box, an ATM box, and various Aerospike databases. While Aerospike is a bit of a mouthful, it may be easier to think of it simply as a cache. There's a variety of ways to communicate with each other. In the case of the bank to node box, it talks to the bank and the bank talks to it at some level over the 9P protocol. This is provided with a series of programs hosted in the Plan 9 port source directory, and also through the 9p.go program that we provided. While Linux does have some basic 9P functionality available within it, in the kernel proper, it does not handle authentication, and so the factotum service is used to handle authentication. That is, factotum has to have your key, this information, and has to be able to authenticate it against the bank. If it can't, then there will be a failure point here. The bank to node box can then be accessed by the node box, and these communicate over a little bit of JSON. So that's really the HTTP protocol. The Aerospike cache relationship to node is a little bit different, but not too much to worry about. That is, it is not really over JSON quite as much as it is simply it's used as a cache of the bank state. The node box can talk to it, and nothing else really talks to it. The ATM talks to the node box, and the node box to the ATM. And this handles what will end up being Green Team's ability to interact with the bank state. And so this will be financiers and so forth. And these communicate over its own protocol. This is technically exposed as a web API, so even if it's not necessarily JSON, you can be assured that it's happening over HTTP. It could be happening over JSON. This is for you to find out. In this case, the way that the flow happens for all of this is the cache will always represent the last known state of the bank. At a given time interval, you can think of this like a cron job with, say, 20 minutes. Every 20 minutes, it will attempt to push things it currently has. It could have, say, a transaction waiting in its queue. It could have an account that was made in a make account command to be pushed upstream. Maybe it has yet another transfer. Who knows? This is just all open. It will take these and it will first obviously travel from the Aerospike cache to the node box. It will then travel to the bank to node box, and the bank to node box will attempt to push it up to the bank. After that, the cache will want to resync with the bank, which then means it will query the state, pull it back down, and it will travel all the way back, and that will overwrite whatever doesn't exist. That is, if these aren't able to percolate all the way up and back to the bank, and the bank doesn't think they exist, they will be erased from the cache state. That is, you will just lose them to the ether because they weren't able to propagate fully. This could be because the bank rejected them. This could be because there's a whole handful of reasons. It could be because factotum didn't work. It could be because your 9p connection is broken. The state of the bank to node box is broken. The JSON HTTP link doesn't work. If you're checking through the ATM, maybe it's not actually synced properly. Maybe your Aerospike cache is just totally corrupted. Who knows? There's a whole slew of reasons. And these are all points for you to debug on your own. Part of this communication structure, of course, relies on all of these succeeding. The bank itself is single-threaded. That is, we know that any operation coming from bank to node will finish after the bank has accepted it and the writes are synchronous. So, with that in mind, we know that after the write to it, say you write and then read immediately after, the next time you read, the state should be accurate, since otherwise your function wouldn't have returned. There's no buffers or queues or anything of the sort, so as a result, the bank can be kind of slow, which is why you have the cache in the first place. This is to speed up this whole operation, and I hope it helps you in your debugging process. Good luck.